Hi, my name is Caleb Patton, and this is Ball&Plate. So, what is Ball&Plate? Well, first off, it's the title that I chose to name my project, and you can see here, basically, this is kind of what it, I hope for it to look like, and it's basically a platform or a flat surface of some sort that's trying to balance a ball in a desired location. Some of the main components is the brains of the operation, a microcontroller, and then the flat surface over here, or here, sorry, and that can vary depending on the detection that's used for sensing the ball's location. Could vary from plywood to a capacitive touchscreen found in most smartphones today. Center support here is holding up the ball and the plate, and motors that are moving the plate about in an X and Y plane, and then the base, which is just a simple construction of whatever, plastic, metal, wood. So some background info. This project's been done by others before. Most have predetermined paths, such as a square that it follows, or a figure 8 or something that it might follow for the ball to follow. Some I've seen incorporate a joystick to use alongside with, for whatever reason I might be using it. So the problem for me is that I have to have the user input a path of some sort that they wish for the ball to follow, and my solution for that is to add a display and then use the touchscreen to identify the location of the user's finger and the ball, and then display the path back to the user on the display. So here's my system diagram. Kind of shows the flow of information. So from the touchscreen, well, to start off, I guess, start here. So the first prompt, basically, it'll be, it'll tell the user to draw a path for the ball to follow, and then here's the user's finger. Hopefully, you're using the finger, not like a pen or laser blade or something. You draw a path onto the touchscreen. The touchscreen then sends that. Well, the display controller gathers that information from the touchscreen and then sends it to the Arduino. Based on, well, actually, I'll back it up. So then, after the user does that, they'll prompt the user to press start and then place the ball on the display. And when they place the ball on the display, it'll then detect, where that ball is through the location of the touchscreen down to the Arduino, and then control the servos to put it to the start of that figure that person had drawn on their touchscreen. And then while they're drawing that, they'll see that the display driver here will send that information to the display and show the user the path that they drew and the path that the ball is following. And here is I also have a reset. So basically, if the user didn't like maybe the path that they drew or something, they can hit that reset button and draw a new path. So electrical components being used here is the microcontroller, resistive touchscreen, the LCD display, the display driver, and servo motors. So the microcontroller that I'll be using is the Arduino Uno, and basically to just reiterate, what's going on here is that, there is an SPI connection between Arduino and this controller here, and the X and Y positioning is gathered from the touchscreen by the controller here, and then sent to the Arduino, and then what's displayed on the screen is my code that's sending it to the driver and then to the display. So resistive touchscreen, basically It's a 4-wire touchscreen, and it's kind of like a potentiometer almost. You kind of see it here, but basically there's a top layer which is flexible, and then there's the resistive coating underneath that top layer, that yellow here, and then a space in between, and then the next yellow layer is the next resistive layer, and then a hard substrate or glass here usually. And basically the way the controller or the driver controls this is, it does it fast, but it'll send 5 volts to one side, or like this here on the positive bus bar here, 5 volts, and then connect this to ground, and then use one of these wires from the other resistive layer to sense the analog voltage there, and then figure out a reading. And that's similar for the Y, so there's X one way and then Y the other way. Okay, so the display that I'm using and the display driver here. So this display you can see is up here, and it features a 7-inch screen, 800 by 480 pixels, a refresh rate of 60 hertz, and it has a backlight that illuminates the whole screen, which is this circuit here, and that requires 9 volts at 125 milliamps. And because of that, the Arduino can't provide that. So there's also other requirements, which is a large video RAM and the pixel clocking for all these 800 times 480 pixels. So that's why I have this display driver here, which takes care of this for me. And there's a lot of supported libraries for the Arduino that I can work off in as well. So it kind of makes my life easier. RC servo motor. It's a 3-wire connection with power, ground, and pulse width. And for the pulse width, the frequency is 50 hertz or 20 millisecond period, and you send it anything typically between 1 millisecond, 2 milliseconds, and that kind of corresponds for 1, 0 degrees for 1.5, 9 degrees, and then 180 for 2 milliseconds. And basically, there's a little circuitry inside this thing, and it feeds back here to the sensor, and then corrects for any error in its positioning. So that's the servo motor. And mechanical parts. The base, which is what I'm using, is a rectangular piece of composite board, center support, a U-joint, that's this here, straight out of a toolbox from home, and then several arms here, which I'm using because the ones that they come with the servo motor is plastic, and I felt that that wasn't probably rigid enough, so I'm using these metal ones. And then the links, several links, are adjustable lengthwise, and they can pivot, so they're kind of like on a ball right here, and kind of pivot, allow for motion. And a steel ball right here, 25 grams or more, because of the touchscreen that I'm using. It says that in the spec sheet it required something fairly heavy. These are the 3D parts that I have or will be printing. The cover, so it's like a bezel or a faceplate, and then that kind of goes over this here, which is the housing for the LCD touchscreen, and it sits down in this here. And this is the same thing, but it's the bottom side of it. And then servo mounts, which are here, center pole here, U-joint adapter here, and ball holder here. And this, you can see that the U-joint that I was using from my toolbox on the previous slide snaps on here and then plugs in here. And this gets kind of like slid down into this hole here and twists and locks in place. So software, two-dimensional array, and memory interfacing with the display, and then servo controller. So I've created a two-dimensional array, and basically, to start off here, this max spots up top here, those are the data points. So that's the number of points that will be taken as the user starts drawing their path. 20 is actually low, it'll be a lot higher, but that's for just testing purposes. I can quickly draw a line or something. So yeah, there's 20 points. And then this is all just declaring and defining. And then this touch read data here is where it actually goes and figures out, where it's being touched. And then I've scaled it down, this X1, Y1 over here, to go from 12 bits to 8 bits, which is important for me because it saves me on the memory, and the Arduino Uno does not have a lot of RAM, so by cutting it down, I can save on memory there. And then this. So if we imagine though that this was 20 dots here, basically, which in the end, like I said, I'll increase that number and there'll be more. But so basically, from dot to dot that's where the ball needs to go to. That's the next position that ball needs to reach. And so I can't have an infinite amount of data points either, because that also consumes a lot of memory. So I had to reduce that as well. And that's part of this two-dimensional array, which I kind of skipped over, but that's put into here, so it's X and Y. So there's 20 X and Y spots that's being recorded there. And then this here is, just storing it into the array. This is a code where it's just storing each time it goes through and reads the data point, it stores it into the array here. And this was just kind of here to show that 8 bits is like, was it 256? So it's, if this was the touch screen here, here's my pointer. This is 256 points, possible points along this way and this way, which is enough resolution for me, so it works. Okay, next. Interfacing with the display. So using that the display driver in the supported libraries, I'm able to kind of find some of the functions that they have and make them what I want them to be. So I use this fill rec or this draw rec, which is filling this in, or making a rectangular shape here, and then at first X and Y positions, and then how long X and Y width and height basically of that rectangle. So, and then coloring it in with the fill, or I guess not fill, draw. So filling it in with green, or, okay, that makes sense. This isn't actually, this is just something I made creative. Okay, anyway, so essentially, yeah, it's filling it in with blue, and then the borders green. Anyway, so that draws these boxes. Basically, that's that the user sees on the display. This is the that display touchscreen right here. So you're seeing that, and then this, like this dotted line here, this is this line here, which it reads the data, finds the point that you're pressing, and then it puts a circle there. So it just puts a little circle about 2 pixels, and those are these points here along the way. And then I have it down here, which is looking for the X and Y coordinates, and this is this is for the reset. So they'll reset it. This is if you press this down here, it's looking for that press anywhere where X is less than 1,000 or Y is less than 1,000. You press here, and it should be true, and then it'll just reset the index, and then you draw a new figure, as I was saying earlier. Servo control, so I just started playing with this and basically just kind of declaring this servo X and servo Y and attaching it to a couple pins on the Arduino, and then writing. So this is 8490. This right here is writing to this anywhere a value between 0 and 180, but 8490 made it so that it kind of was level, even if the picture is not really straight on. But this is kind of level in both X and Y plane. So, and this here you can see where it's tilted bottom left corner here is kind of tilted. It requires a write of 25 and 45. So my budget for this was actually decreased, which is good news, I guess. But display with the touchscreen was 48, driver controller for display 35, steel ball 12, servo motors 25 apiece, lever or linkage arms for those servo motors 20 piece, and then center support structure mount 10, miscellaneous 25, which is a total of 150. And so some issues that I've had a lot of issues, but basically touchscreen testing. I was, one day just trying to read on the serial monitor the presses that I was making on my touchscreen, and so I thought at the time that it was this board here, so I went ahead and ordered a new board. And I kind of figured out, which held me back a little bit, and one of my milestones, which I figured out, was actually just this ribbon cable, which is that 4-wire touchscreen coming up over, and it was like, it was broke right in here or something, and not a good connection. So it was not it wasn't the board, and I found that out once I got the new board and hooked it all up. And then another issue I had, which I recently just found out as I was kind of putting this all together, constructing it, which is another one of my milestones, was that I was using this camera mount, and that's when I figured out that it was yawing too much, or it was pivoting too much, and that's kind of a huge issue if somebody's trying to draw on it and it's like, moving all about for them. You can't really, draw anything on it at that point. So I got rid of this and I switched to that U-joint. And the other milestone I haven't mentioned yet is adapting the structure pole to the housing. So this 3D part here, that was a little bit of a task. It took me, a little bit to figure out, how am I going to get all this to kind of mount to a display and the touchscreen of its own. So that's when I came up with the housing, and then, with that housing, how am I going to attach to that housing? So I came up with this piece here, and originally, because I was using this is a quarter 20 bolt here, I was able to grab one of those well nuts, I think you call it, for the 80-20 strut, I guess. And that was originally to slide down in there and then twist and lock as you tighten that, which was kind of clever, and I was able to just take this and attach it to the back side of my my housing for the touchscreen and display. And this is that last previous slide milestone, constructing it all together. And this is good because now I can take this and I can start to kind of characterize my system and come up with the controls for keeping that ball on top of that platform. And so that's kind of where I'll be heading as well. And that's it. Yep.